Solar System or Alpha Centauri? Which is better for hosting life? Would it shock you if Alpha Centauri turns out to be a better home for life than our very own solar system? Let's dig deep in today's episode. Ever imagined holding a slice of human anatomy in your hand? What if you could study the human body while playing your favorite card games? Now you can, with the Body Deck. What's the Body Deck? A high-quality deck of translucent playing cards that stack to form a 3D cross-section of the human body. It's science, art, and fun. In other words, pure genius combined. Each card is a slice of anatomy, letting you build, study, and explore like never before. Play classic card games, test your anatomy knowledge, or construct the tallest house of cards. Just don't let your liver collapse. What do you say? Do you want it? Well, amazing news for you. We're giving it away for free. Subscribe to the Curiosity Box quarterly, and you'll get the Body Deck as a free gift. Just pay shipping. Prefer saving on your subscription and going annual? You'll get the Body Deck and the Lightyear bottle, also completely free. That's what we call an offer you can't refuse. These aren't just any collectibles. They're limited edition science experiments that only a select few will ever own. This deal is automatically applied at checkout, but once it's gone for good. So don't just watch science. Own it, play with it, and explore it. Click the link now and secure your subscription before this exclusive offer disappears. When scientists search for life beyond Earth, they're not just looking for random planets that seem cool. They're following a checklist. Think of it like house hunting, but the stakes are cosmic. The goal? To find a star system where planets can host life. But what exactly makes a good host for life? Let's break it down into the essentials. First, we have water, everyone's favorite molecule. Life as we know it doesn't just like water, it requires it. Liquid water is the universal solvent, the medium where all the chemical reactions of life take place. It's what allows organisms to grow, metabolize, and reproduce. Wherever we find water on Earth, we find life, whether it's in the scorching hot springs of Yellowstone or the crushing depths of the Mariana Trench. So any system with planets that can support liquid water instantly gets a big check mark on our habitability list. But water isn't enough by itself. Planets also need an atmosphere, the invisible shield that keeps things stable. An atmosphere serves two key roles. First, it helps regulate temperature, preventing the planet from freezing into an ice cube or roasting like a marshmallow left too close to the fire. Second, it acts as a barrier against harmful radiation and space debris. Without an atmosphere, life would face a brutal fight for survival. Just look at Mars. It once had rivers and lakes, but after losing its atmosphere, it became a barren desert, its surface bombarded by solar radiation. Next up, magnetic fields. These are like a planet's personal bodyguard, deflecting harmful solar winds and cosmic radiation. Earth's magnetic field is the reason we aren't constantly fried by the sun's radiation. Without it, our atmosphere would be stripped away over time, just like what happened to Mars. For a planet to stand a chance at hosting life, it either needs a strong magnetic field or some other way to keep its atmosphere intact. Of course, none of this matters if the planet doesn't have a reliable energy source. Life needs energy to thrive, and stars provide it in abundance. Our sun, for example, bathes Earth in light and heat, powering everything from photosynthesis to weather patterns. But not all stars are created equal. You want a star that's stable and long-lived, providing a steady source of energy for billions of years. Stars that flare up unpredictably or burn out too quickly make it difficult for life to evolve. This brings us to the concept of the habitable zone, often called the Goldilocks zone. It's the region around the star where temperatures aren't just right, not too hot, not too cold, for liquid water to exist. If a planet is too close to its star, any water on its surface will boil away. Too far, and it'll freeze solid. But being in the habitable zone isn't enough on its own. Venus and Mars are both technically within the Sun's habitable zone, yet neither is exactly a paradise. Habitability depends on a delicate balance of many factors, including atmosphere, temperature, and geological activity. Let's not forget geology, a planet's internal activity. Think earthquakes, volcanoes, and plate tectonics can play a huge role in sustaining life. For one, it helps recycle nutrients and maintain a dynamic environment. On Earth, for example, volcanic activity releases gases that replenish the atmosphere and regulate the climate over long timescales. Without these processes, planets can stagnate and become lifeless hulks. Finally, the stability of the star system itself is a critical factor. You don't want your potential life-hosting planet to be in a neighborhood prone to chaos. Stellar flares, asteroid bombardments, or the gravitational tug-of-war between multiple stars can make conditions unpredictable and hostile. A stable star system provides a calm environment where life has the time and space to evolve. So keep in mind our checklist: liquid water, a stable atmosphere, a magnetic field, an energy source, geological activity, and a stable environment, as we peel more layers to the question of whether our solar system or the Alpha Centauri system is the better choice for life. Why does this matter? Because comparing the solar system and Alpha Centauri isn't just a fun thought experiment. It's about understanding our place in the universe. Earth is our home, but it's just one planet in one system out of billions. If we can find other systems that meet these criteria or even exceed them, it changes everything we know about life and its potential to exist elsewhere. And in a universe as vast and mysterious as ours, who wouldn't want to explore those possibilities? The solar system is our home turf, the place we know best, and it's undeniably the champion of habitability. For now. Earth is the star player here, the perfect combination of liquid water, a breathable atmosphere, a magnetic field, and an energy source that's been steady for billions of years. But what about the rest of the solar system? Could it have other contenders for hosting life? And how does it compare to the untapped potential of Alpha Centauri, our closest celestial neighbor? Let's start with the solar system. Everyone knows Earth's story, but the other planets and moons are where things really get interesting. Mars, for example, might not seem like much now, with its dusty red surface and thin atmosphere, but its past paints a very different picture. Scientists have found evidence of ancient rivers, lakes, and even a massive ocean that once covered much of its northern hemisphere. Today, we know there's still water on Mars, though most of it is frozen underground or locked up in polar ice caps. And while the surface is harsh, cold, dry, and exposed to dangerous radiation, there's hope that life could still be lurking below ground, where liquid water might persist in salty brines. Mars represents the solar system's greatest what if. What if life once thrived there? And what if it still does? But Mars isn't the only potential player. Let's talk about the icy moons. Europa, one of Jupiter's largest moons, is one of the most promising candidates for alien life in the solar system. Beneath its thick, icy crust lies a vast ocean of liquid water, kept warm by tidal forces from Jupiter's immense gravity. These tidal interactions create heat through friction, preventing the ocean from freezing solid. Europa's ocean might have more water than all of Earth's oceans combined. Imagine an entire ocean world, shielded from space by a thick layer of ice with hydrothermal vents on the seafloor providing heat and nutrients. On Earth, hydrothermal vents teem with life even in complete darkness. Could the same be true for Europa? Enceladus, a smaller moon of Saturn, is another fascinating candidate. Like Europa, it has a subsurface ocean, and we know this because Enceladus is literally shooting water into space. At its south pole, geysers erupt through cracks in the ice, spewing water vapor, organic compounds, and even tiny grains of rock from the ocean below. These plumes are like a giant cosmic invitation, practically begging us to investigate. Scientists suspect that hydrothermal activity on Enceladus' seafloor could create the kind of chemical energy needed to support life. If microbial life exists anywhere beyond Earth, Enceladus is a strong contender. And then there's Titan, Saturn's largest moon. Titan is weird, and that's what makes it so intriguing. Its surface is covered in lakes and rivers, but they're not filled with water. They're filled with liquid methane and ethane. At first glance, this might seem like a deal breaker for life. After all, life on Earth depends on water, not methane. But some scientists believe that exotic forms of life could potentially exist in Titan's methane lakes, using completely different chemistry to survive. It's a wild idea, but Titan shows us that habitability might not always look like what we expect. Of course, the solar system isn't perfect. Aside from Earth, none of these worlds have been proven to host life, and exploring them is incredibly challenging. Europa and Enceladus are locked beneath miles of ice, requiring advanced technology to drill or melt through the crust. Mars is much easier to access, but so far we've only scratched the surface, literally. And while Titan is fascinating, its frigid temperatures make it seem like a long shot for life as we know it. The Sun, while stable now, also has an expiration date. In about 5 billion years, it'll expand into a red giant, swallowing the inner planets and turning the solar system into a very inhospitable place. So while the solar system has a lot of promise, it also comes with significant challenges. Now let's turn our attention to Alpha Centauri. At just 4.37 light-years away, it's practically next door in cosmic terms. But Alpha Centauri is a very different kind of system. Unlike the solar system, which has a single star, Alpha Centauri is a triple star system. Two of its stars, Alpha Centauri A and B, are similar to our Sun, stable, long-lived, and bright. The third star, Proxima Centauri, is a small red dwarf much farther out. And here's where things get interesting. Proxima Centauri has a planet, Proxima Centauri B, that sits in the habitable zone. Proxima Centauri B is roughly Earth-sized, and its position in the habitable zone suggests it could have liquid water on its surface. That's a big deal. But before you get too excited, there's a catch. Proxima Centauri is a red dwarf star, and red dwarfs are notorious for their violent temperaments. Proxima frequently unleashes powerful stellar flares, bombarding its planets with intense radiation. Without a strong magnetic field or thick atmosphere, any water on Proxima B's surface would likely evaporate, and the planet itself could be stripped of its atmosphere. We don't know yet if Proxima B has what it takes to withstand these flares, but if it does, if it has a magnetic field or some other form of protection, it could be one of the most exciting places to study. Alpha Centauri A and B, on the other hand, are far more promising from a stability perspective. These two stars are much more like our Sun, with steady energy output and long lifespans. Each has its own habitable zone where Earth-like planets could potentially exist. The problem? We haven't found any planets around Alpha Centauri A or B, at least not yet. There are hints of a Neptune-sized planet around Alpha Centauri A, but nothing Earth-sized has been confirmed. Still, the search is far from over. With next-generation telescopes and advances in planet detection methods, it's entirely possible that we'll discover hidden worlds in these habitable zones. One of Alpha Centauri's biggest advantages is its proximity. At just over 4 light-years away, it's the closest star system to Earth. This makes it an ideal target for interstellar exploration. Projects like Breakthrough Starshot aim to send tiny laser-powered spacecraft to Alpha Centauri within a few decades. If successful, these probes could give us our first up-close look at another star system, complete with images and data from its planets. Imagine what we could learn if we could directly observe Proxima B's surface or study the atmospheres of planets around Alpha Centauri A and B. So, here's the big question for you. If you had to pick one system as the better host for life, which would it be? The solar system with its proven track record, or Alpha Centauri with its untapped potential? Let us know what you think in the comments. When we compare the solar system and Alpha Centauri, it's like comparing an old favorite book to a thrilling new mystery. The solar system is familiar, reliable, and full of exciting possibilities. Well, we've already read most of its chapters. Alpha Centauri, on the other hand, is the great unknown, a story that hasn't been written yet but holds the promise of incredible discoveries. We're essentially weighing the comfort of the known against the thrill of the unknown. The solar system, for all its mysteries, is familiar territory. We've sent probes to its furthest reaches, landed humans on the moon, and even explored planets and moons with rovers and orbiters. Alpha Centauri, on the other hand, is uncharted waters. It's close enough to spark our curiosity, yet distant enough to remain elusive. So, how do we make the final call? Let's break it down. The solar system's strongest argument for being the better host for life is its proven track record. Earth, of course, is the crown jewel. It's the only planet we know of so far that harbors life, and not just microbes or extremophiles, but complex, intelligent life capable of gazing at the stars and wondering about its place in the universe. Earth works because it checks all the boxes: liquid water, a breathable atmosphere, a magnetic field, a stable energy source, and geological activity that keeps the planet dynamic and habitable. No matter how intriguing Alpha Centauri may be, it can't match the certainty of Earth. But Earth isn't the solar system's only asset. Europa and Enceladus, with their hidden oceans, are tantalizing prospects for alien life. These moons may lack sunlight, but they have something equally valuable: geothermal energy. On Earth, hydrothermal vents at the bottom of the ocean teem with life, even in total darkness. Europa and Enceladus might host similar ecosystems, sheltered beneath their icy shells. Then there's Titan, whose methane lakes challenge our assumptions about what life needs to survive. And Mars, with its ancient riverbeds and potential for underground water, continues to tease the possibility of past or even present life. The solar system also benefits from being relatively stable. The Sun, despite its finite lifespan, is a steady, middle-aged star with billions of years left to burn. Its gravitational influence keeps the planets in predictable orbits, and while asteroid impacts and solar flares are occasional threats, they pale in comparison to the chaos that can occur in multi-star systems. Thanks to this stability, life on Earth has had billions of years to evolve and thrive. But the solar system isn't without its flaws. For one, most of its habitability potential is locked away in difficult-to-reach places. Europa's ocean, for instance, is buried under miles of ice, making exploration a monumental challenge. And while Mars is within reach, its surface is harsh and exposed to radiation, making the search for life a slow and painstaking process. Then there's the ticking clock of the Sun's life cycle. In about 5 billion years, it will expand into a red giant, engulfing the inner planets and rendering the solar system uninhabitable. While this might seem like a distant concern, it's a reminder that no system lasts forever. Alpha Centauri, by contrast, represents the allure of the unknown. Proxima Centauri b, orbiting the red dwarf Proxima Centauri, is its biggest draw. At roughly Earth's size and sitting within the habitable zone, it's one of the most promising exoplanets we've discovered so far. Could it have liquid water, an atmosphere, life itself? The answers hinge on factors we don't know, like whether it has a magnetic field strong enough to protect it from Proxima's frequent stellar flares. The flares are a major hurdle. Red dwarfs like Proxima are notorious for their temperamental behavior, and those flares could strip away a planet's atmosphere or sterilize its surface. But if Proxima b has managed to hold on to its atmosphere and water, it could be a fascinating world, potentially even more habitable than Mars or Europa. Then there's Alpha Centauri A and B, the more solar system-like stars in the trio. These sun-like stars are stable and long-lived, offering the kind of steady energy output that life needs to thrive. Each has its own habitable zone where Earth-like planets could potentially exist. The problem? We haven't found any planets around them yet. But that doesn't mean they're not there. Our current technology is still improving, and it's entirely possible that hidden worlds orbiting these stars will be discovered in the near future. If we do find planets around Alpha Centauri A or B, they could rival Earth in habitability, especially since these stars aren't plagued by the violent flares of Proxima Centauri. To summarize all of this, Alpha Centauri's biggest challenge is its uncertainty. The solar system might have proven habitability, but Alpha Centauri is a fun gamble to think about. Proxima b might be a fascinating world, or it might be a radiation-scorched wasteland. Planets around Alpha Centauri A and B might exist, or they might not. The lack of concrete data makes it difficult to give Alpha Centauri the edge, at least for now. For now, the solar system holds the crown, but Alpha Centauri remains the contender to watch. As our technology improves and our reach extends beyond our own backyard, the day might come when Alpha Centauri outshines the solar system in its ability to host life. Until then, we'll keep exploring, searching, and asking the big questions. If you enjoyed this journey through the cosmos, don't forget to like the video, subscribe to the channel, and let us know in the comments which system you think is better for hosting life. And as always, stay insanely curious.